So I will be recording this session and I will be able to send the recording out to everyone who registered after the webinar as well. So you should be able to see my screen. Give me 1 second. You should be able to see my screen now. Okay, so hope everyone is well. Welcome to Guralp's first webinar of our AGU series. Today I will be talking to you about the Certimus, which is Guralp's latest broadband seismometer with an integrated minimus digitizer. For those of you that don't know me already, my name is James Lindsay. And I am the regional sales manager for Guralp, who's responsible for our projects in the Americas. So I plan to talk to you guys for about 30 minutes today about the Certimus and its potential applications within the seismic community. And then after that, I'll give you guys an opportunity to ask me some questions and I will do my best to answer them. So if you do have any questions that come up during the talk, could you please post them using the chat function, and I will read through them in the order that they're posted at the end of the session. So here's the first overview of the Certimus and the two variants that we are manufacturing. So on the left, we can see the surface variant, which has this touch-sensitive LCD screen on the top side of the instrument. This allows the user to quickly and easily access state of health information directly from the instrument. So you can view these in a tabulated format via the main menu, or you can look at the live waveform data, as you can see on the image on your left. This surface variant also has Bluetooth enabled, so that you can use the Guvu smartphone app, which is available for Apple and Android devices, to also monitor the state of health parameters of the instrument whilst it's deployed. You can also use this to view the live waveform data. So the second variant that we are producing is the direct burial variant, which we can see on the right-hand side. So the main difference between this and the surface variant is that this variant does not have the touchscreen LCD screen. Performance-wise, it will act identical to the surface variant. It just doesn't have this touchscreen included. And the reason we have decided to produce this second variant is to make something slightly more robust for situations where you're directly burying the instrument. What we wouldn't want to have happen is for a user to try to dig out their seismometer when it's buried and accidentally damage the screen, for example, with a sharp tool like a shovel. So the idea behind this direct burial version is to produce something, a slightly more robust alternative for direct burial situations. Another consequence of not having the LCD screen is that the instrument itself doesn't have Bluetooth connectivity, but we have ways around that, which you will see in a few slides' time. We can also see the general dimensions and weight of the instrument just at the bottom of the screen. So we can see that this is a very compact unit, which of course includes the sensor and digitizer components, weighing in at just 4.4 kilograms. So moving on to the performance then of the Certimus. As I previously mentioned, the surface and burial variants are both identical in terms of performance. So the sensor is advertised with a flat frequency response between 120 seconds and 100 hertz. However, because the sensor feedback system has digital components integrated, this is actually user configurable, and this can be configured just prior to deployment or midway through deployment. It's really up to the user. So you can configure the long period corner to settings of 1 second, 10 seconds, and 120 seconds. So the idea behind this feature is to give users incredible versatility, essentially giving you several instruments in a single package, whereas previously you would need 3 separate sensors with these different long period corners to meet certain needs. Now with the Certimus, we're moving in a direction where this one instrument can perform those different niches. So part of the digital feedback system within the sensor actually also allows the instrument to operate at angles up to 45 degrees. This is a feature that started off with the radian post-hole and borehole system, which was released back in 2016. This sensor technology was then developed further for the Aquarius OBS system, which was released last year. And now we've taken this further and repackaged it into a surface instrument, the Certimus, which has the same characteristic of working at angles up to 45 degrees. So because of the digital feedback system, it's also has the ability for the user to configure which features are turned on and off. And by turning certain features off, you can put the instrument into an ultra low power mode, which takes the power consumption down to less than 300 milliwatts. This is significant compared to the normal case scenario power usage of 2.2 watts. So by putting it in ultra low power mode, you are significantly reducing your energy requirements. The trade-off for this feature, this is assuming that data is only being recorded locally. The GNSS will lock on once every hour to sync the data in terms of time, and data, is only being stored locally. So this is the trade-off for having this ultra low power mode. But we believe this is crucial, especially for remote deployments, where it's not necessarily easy to access power, and so small solar panels with small batteries are usually all is available. So I mentioned earlier that this is a integrated seismometer, i.e. there is a sensor and a digitizer within the single package. The Certimus has the Minimus digitizer integrated within this package. So this was released back in 2016 and has proved incredibly popular since then. So therefore the Certimus has the same digitizer features as the standalone Minimus. So this includes things like STA, LTA triggering on board, and compatibility with our Discovery software. So the engineers at Gural worked very hard to make sure that there wasn't little to no noise compromise for having these features available. So this is the Certimus self-noise plot, and we can see at the lower frequencies, it's particularly comparable and actually better than the previous generation 6TD and 40TD instruments. And the engineers have managed to do this by isolating the digitizer components from the sensor components within the package. This is an inherent issue with combined seismometers in the past. The digitizer components in close proximity to the sensor generally gives some high frequency noise, but the Certimus is designed in such a way that these components are isolated, which therefore produces a really good self-noise plot. So I mentioned earlier that the Minimus digitizer is integrated into this sensor, and this allows for use with our discovery software. So this is supplied free of charge to all GURAB customers, and allows for simple instrument data management and access to the hardware state of health. So on the bottom image on the right, you can see a quick overview of your stations within a network. You can instantly assess using the traffic light system whether there is an issue with timing, storage, or the system as a whole. So you can also view the waveforms in real time. This is shown in the top right-hand image. The discovery also allows for some data analysis, allows you to plot PSDs, spectrograms, DFTs, and histogram displays from your Certimus data. It gives you quick access to the locally stored data and allows you to download it, and can facilitate the remote upgrade of firmware. So the firmware can be upgraded free of charge and can be upgraded remotely, which is a significant advantage for those of you who are operating with remote networks. It also gives you a quick and easy way to access the digitizer web page, which is where you would configure the Certimus with things like the adjustable long period corner. So we know that there are more to deployments than just the instrument itself. Other things that need to be considered include transportation of the equipment, power, and data acquisition. So GURAB have designed a few key optional accessories that can be purchased or can be supplied alongside the Certimus in order to improve quality of life when installing the sensor. So on the left, we can see a deployment backpack. So this is a protective ruggedized backpack, which has included custom foam inserts, which protects the Certimus and the accessory pack. So it can house those two and can allow a single person to transport the instrument and accessory pack into the field. So by doing this, we're greatly reducing the logistical need for manpower for transporting sensors into the field. In the middle, we can see the portable power module, or PPM. You might see it referred to as. This is a GURAB-made lithium-ion battery pack that has a power out and a power input port. It has enough storage to allow the Certimus to operate for up to 6 weeks autonomously when it's set into this ultra-low power mode that I mentioned earlier. So you can get up to 6 weeks of autonomous deployment with this. It also has a inbuilt charge controller, so you can easily attach a small solar panel in order to charge your system or just to charge the battery. And then on the right, we see the surface storage module. This might also be referred to as the SSM. So this is a really clever bit of kit that attaches to the GPS input of the Certimus. So you would bury your Certimus within the first few meters of the ground. The SSM would be connected to the instrument's GPS port. The SSM, so this black semicircular object, would sit on the surface, and then you would have the GPS receiver connected in line with this SSM. So you can see a small cap on the face of the SSM there. Housed inside that cap would be one of the instrument's dual redundant micro SD cards. So supplied with the instrument, you get 2 dual redundant micro SD cards. So in this case, you would place one of those inside the cap of the SSM. So this would allow you to easily go into the field, retrieve your data from the SSM in the form of the micro SD. You could swap in a completely clean, fresh micro SD card and continue to record data locally without disturbing the instrument whilst it's buried. So your instrument throughout this whole process will remain buried and will remain undisturbed during this process. So it's just a very quick and easy way of retrieving data in the field. So we're going to talk a bit about the different applications for the Certimus within the seismic community. So I've broken these down into different industries. So to start with, we'll talk about the energy industry and the possible applications of our sensors here. So some typical energy industry applications for our sensors in the past have been, firstly, for passive seismic imaging surveys. We've had customers who have used our sensors for exploring hydrocarbon reserves using passive seismic tomography. We've also had our sensors used for reservoir health monitoring. Some operators would like to monitor for background seismicity, see if this will have any effect on the reservoir. Alternatively, they have used our sensors for induced seismicity monitoring, so the result of operations, as well as for any results of geothermal well monitoring. So often pilot holes are drilled for geothermal wells, and the response of the ground to this drilling is quite often monitored. This can be said also for wind turbine monitoring. We've had users in the past use equipment for monitoring how the ground responds to the movement of wind turbines, as well as monitoring for natural seismicity and how this might affect potential wind turbine sites. So this is just a general overview of some of the applications that previous generation instruments have been used for in this industry. So more specifically to the Certimus then, we can see that the user configurable long period corner feature might come in a lot of help for this situation. Typically, if an instrument is 120 seconds long period corner, it could take quite a bit of time for the instrument to settle and to start recording good quality data. So by having the ability to change the Certimus's long period corner to say 10 seconds or 1 second, the user is going to get high quality data much quicker, which will allow for rapid data retrieval. Typically, especially in the case of seismic, passive seismic studies, the data is only recorded over the space of a few hours or overnight. So this is a particularly useful feature. When paired with the portable power module, PPM, the Certimus can operate for up to 6 weeks autonomously. This is great for temporary studies and temporary surveys that quite often happen in the energy industry. But it should also be added that even when the Certimus is operating in full power mode, so around 2.2 watts, you can also get up to maybe 4 or 5 days of autonomous deployment. So this is also of interest for passive seismic studies, for example. The small form factor means that you can deploy many sensors and you can transport many sensors in one trip. So this is improving the data density that operators can get from having a small compact instrument, especially when the sensor and digitizer is combined into one package. There's less equipment to carry, and you can combine this with the deployment backpack in order to get a really small form factor set of equipment for deployments. By making a direct burial version, you can improve the coupling of the sensor with the ground and reduce the effect of cultural noise by quite significantly, even by burying up to a few meters. So this was one of the motivations for designing a specific direct burial version, and then this can be combined with the surface storage module, or SSM, to allow operators to retrieve data quickly and efficiently without disturbing their instrument. So if an event is recorded overnight, for example, and they would like to see data from that event, but they would like to keep their instrument operating in the ground, they can then go and retrieve the data and place a new SD card in and keep recording. So this is how the accessories that GuruUp have designed have really helped to improve the quality of life for operators. So the second industry we're going to talk about is the engineering industry. So previously, GuruUp sensors, so the 6TD and 40TDE is what comes to mind typically for these applications. These have been used for a number of scenarios, ranging from civil engineering scenarios to earthquake early warning systems. So the most popular use for the previous generation 6TD instrument or 40TD instrument was for HMV studies, or the Nakamura method. So this is a method that makes use of short terms of ambient noise measurements to calculate the depth of bedrock using variations in the impedance between the layers. These studies typically make use of broadband sensors deployed for just a few hours and are typically redeployed very quickly so that users can get a high amount of data density. Baseline measurements are typically done in conjunction with force balance accelerometers when monitoring structures like dams or tall buildings. By providing broadband data from slightly further afield of the study site, users can get an idea of the background seismicity upon which to base their more specified recordings from the structure. This is also done with earthquake early warning systems. Broadband sensors are used to detect some of the smaller events in order to calibrate the entire system. And then finally, we have anthropogenic noise studies. Medium motion sensors are usually used in this scenario purely because the nature of the signals being recorded. So looking more specifically then, we see again that the user configurable long period corner really comes in handy here again. By being able to switch that down to 1 second or 10 seconds, the user can use the Certimus much like they would use a short period sensor in order to collect data very quickly. But then they still also have that option of switching it to 120 seconds and effectively using it as a truly broadband sensor. In addition, the Certimus has PoE, power over Ethernet enabled. So this would be useful within a building, for example, where cabling can be quite a confusing feat. So by being able to supply power over the supplied Ethernet cable, you're reducing the amount of cabling that was required. So therefore, you're making it a much more efficient setup. As long as the Ethernet cable is connected to a PoE-enabled Ethernet switch, you can provide power over Ethernet. So mentioned earlier, the integrated Minimus digitizer has the STA LTA triggering enabled. So the sensor itself has the ability to send alerts when it detects an event that exceeds this STA LTA threshold. So that means that the sensor can send a UDP packet or a CAP message to a designated receiver in the event that a triggered event is detected. This is very useful for small-scale earthquake early warning setups, whereby networks need to basically alert the end user that an event has happened exceeding a threshold and some action needs to take place based on that alert. It can also be used to calibrate and act as a fail-safe for more complex earthquake early warning networks. So the high sensitivity, because of the digital feedback within the Certimus, it had an equivalent sensitivity of 2000 VMS. This is useful for HIV studies in particular. It also has the ability to sample up to 5,000 samples per second. This is very useful for situations when data is required instantly and very quickly. For example, earthquake early warning situations. It's also useful for HIV studies where data density is a priority. You can also view the data in real time, as mentioned earlier. Over Ethernet, the data can be transferred in real time. Because of the integrated Minimus digitizer, data can be transmitted in industry standard seedlink or GCF or GDI formats, which have different uses. GCF is generally more efficient, whereas GDI has a ultra low latency and is well suited for earthquake early warning scenarios. So the image on the right here we can see is from a study in Pakistan that was using 6 TD instruments to perform a HIV study. So in the future, we hope that the Certimus will be used for very similar situations. So finally, we're going to take a look at seismic monitoring applications, so within the research industry. So obviously here there is a very wide range of applications for broadband sensors, small compact broadband sensors. So aftershock studies particularly place an importance on sensors being small, light, transportable. They need to be easy to set up and easy to deploy. So this is because of the urgency that is required after a large event to get sensors on the ground to record useful data. Volcano monitoring is also very similar. These can sometimes be difficult environments to deploy instruments in because of the environmental conditions. So by having a sensor that is easy to deploy and doesn't necessarily need to be leveled and won't be affected by changing ground movement so much, it's very useful for the Certimus to be used for these situations. We also have tomographic imaging and regional seismic networks, which make use of small, compact broadband seismometers across the globe. The last two applications are very interesting because they are generally monitoring dynamic environments. Both glaciers and landslide-prone areas, typically the ground movements can cause issues for conventional broadband sensors that need to be perfectly leveled to operate. We hope that with the Certimus we can offer a novel solution for addressing those needs, whereby the sensor won't actually be affected by the changing ground movement and will continue to record good data. So this is especially important in remote areas where you don't necessarily want to be going back to replace your instrument or check on your instrument constantly. So this is, again, part of the motivation of designing the Certimus to have this omnidirectional functionality. So again, the user configurable long period corner will come in handy for seismic studies. And as mentioned, the lightweight and compact design will really help with installations in remote areas by being able to place the instrument in a backpack with the accessories and have one person transport that to the installation site is really, really important and can help significantly when planning a project. The low power mode also helps with this kind of theme as well, because by having this lower power option, the user can choose to downscale the energy requirements. So the size of solar panel, for example, the size of the batteries required, which can make deployments a lot easier in the long run. The 64GB dual redundant micro SD cards. So with the Surface variant, this is extracted just through a port at the back of the instrument, or it can be placed in the Surface storage module as discussed previously. This is quite a lot of storage in comparison to other similar products on the market. And it means you won't necessarily need to worry too much about using up all of your memory. But the fact that they are hot swappable just means that you can easily replace them in the field. And as mentioned earlier, the SSM facilitates that better for direct burial situations. The Certimus also has robust mil-spec connectors for the Ethernet, power, and GPS units. So this helps to protect against the ingress of moisture, overall helping to seal and protect the instrument from environmental issues. So the Certimus has been field tested already in Iceland by the University of Cambridge. So I'd like to say thank you to Nick Rawlinson, Connor Bacon and Tim Greenfield, who have collected the data from the Certimus units and allowed us to present some of their data. So on the left-hand side, we can see that these are earthquakes from Iceland's national catalogue between June and August of 2020. The Reykjanes Peninsula has been very active this year, as you can see, with a series of magmatic intrusions near the town of Grindavik. So this has caused uplift, which has much higher than usual levels of seismicity. So whilst research is currently ongoing, the large swarm stretching from the southwest to the northeast is representative of a large strike slip fault, which has probably been activated due to the uplift. And during August, there's been a series of magnitude 4 and above earthquakes detected along this fault. So on the right-hand side, we can see some travel time graphs, which have been plotted for the Certimus and 6TD units, which were deployed in the region. So since August, the activity has actually shifted eastwards, and there's been triggering of more large earthquakes in the area. So the high levels of activity along the peninsula this year could be a precursor to a significant magmatic episode along this section of the rift. However, the previously high activity levels, at least 2 recorded in the 20th century, have previously fizzled out with no eruption. But we can see here on the right, the Certimus, well, you can see the result of the Certimus station. So it's been deployed just under those rocks on the right-hand side and is connected to a laptop via Ethernet so that the deployment team can check the state of health of the instruments and make sure that they're recording good data. We can also see on the left some frequency plots from the instruments, including Certimus and 6TD. And we can see that the results are comparable between the two. So that's it from me in terms of the Certimus. Thank you very much for listening. I just wanted to make you guys aware that we do also have some more webinars coming up this week that might be of interest. So tomorrow, my colleague will be presenting on the Aquarius free-fall OBS system at 4 o'clock GMT time. Thursday, myself and my colleague Sean Goosen will be presenting on using ObsPy with minimus data. And on Friday, we'll be finishing up again, talking about the Certimus digital accelerometer. So these are all completely free and open to anyone to join. You don't necessarily need to be registered to AGU to attend one of these talks. But if you are registered to AGU, please feel free to drop by one of our poster sessions. We have one on the Aquarius that we'll be talking about tomorrow. We also have another interesting poster on the use of broadband systems within smart cables, with a focus on Guralp's implementation and project overview of the INGV wet demonstrator. We also have another oral session based on the Certimus. that will be taking place next Monday. So here are my contact details. If you have any questions, I'll now have a look through the questions in the chat. So the first question I have is from Claudio regarding the self-noise curve. He asks, do you have any data on the 10 to 100 hertz noise for microseismic applications? So the noise plot that I had in the presentation is real data and is what we have at the moment and is what we publish on our data sheets. I'll make a note of your request and see if we can look into perhaps making a specific noise plot for 10 to 100 hertz for you. So I'll write that down and I will get back to you, Claudio, on that at a later date. So another question from Will. I will unmute you. I feel like you have something to say on that. Sorry, Will, you're muted.
Is that better?
Perfect.
Okay. Claudia, I just noticed your message. We do have the rest of the curve. Unfortunately, it's not in a format that we can share on this platform. But for the 10 to 100 hertz band, we're currently below 130 decibels. The actual noise testing we've done has focused more on the long period end of things. So we haven't focused too much on the high end. The results we have at the moment are affected quite a lot by propagation through concrete. So if we wanted to do a full test to find the true noise, we'd likely be around just under 135 decibels for up to around 100 hertz, but we can clarify that, as James said.
Thanks, all. So in terms of real-time data transmission options, Claudio, so with the Certimus, we supply a Ethernet cable, which can obviously be plugged straight into any existing network. We can also supply GPT modems or cell modems to transfer the data in real time via cell coverage. But we have had users in the past use our sensors to transfer data over real time using radio modems or VSAT systems. Okay, next question. I have a question from Dr. Deepak. Does Gural have or own software for HFV analysis and SPAC method? How about data format conversion software? So we don't have our own proprietary software for this analysis. I'm sure we've worked with partners in the past who can provide this software. In terms of data conversion software, it really depends what you would like to convert from and to. I know we have some programs for converting between, I think, GCF and SegWi data. But if you have something more specific in mind, please feel free to email us and we can get back to you with a solution. Question from Suleiman. What is the dynamic range of the sensor? That is a good question. I will just have a look at that for you. So the dynamic range of the Certimus is 149 decibels. So that information can be found on the data sheet, which can be found on our website. If you have any other queries about instrumentation, all of our data sheets and manuals are found on our website. So I have a question from Paulinho asking, is there any option in a post-hole case? So whilst the Certimus doesn't have a post-hole dedicated variant, we do actually have the sensor technology is based on the Radian system. So the Radian is essentially the same sensor that can work at any angle. And this does come in a post-hole variant. So if you'd like to find out more information on that, you can find the datasheet and manual on our website, or feel free to email or get in contact and we can let you know more about the Radian post-hole system. Okay, a question from Simon Irwin. Is the surface storage unit in line with the onboard Minimus communication link from the sensor to telemetry, or is it a separate connection? So the surface storage unit connects in line with the GPS. So the surface storage module will connect to the Certimus GPS port, and then the GPS will connect straight to the surface storage module. So it's only for being used when collecting the locally stored data physically. So if you physically want to collect the micro SD card in the field, you can remove the cap and hot swap the micro SD card that way. Okay. Don't see any more questions. Will, I see your hand is raised. Is there something you'd like to add?
No, I think I raised my hand earlier in the session to try and answer a few questions, but I think they've basically all been asked. Just to mention on the post-hole case from Paulino, the burial version is rated to go down to fairly far. So in most post-hole cases, we're usually talking down to about 10 meters. All of the connectors will manage that very easily. And if it's a particularly tricky installation in terms of actually lowering it down the hole, then we can come up with a solution of a particular mechanism for lowering it, although it's fairly simple to lower down. And the added benefit that we don't have to level it once it reaches the bottom of the hole does mean that we don't have to worry about it being off horizontal when we reach the bottom. So the idea that it can work at any angle is particularly useful in that kind of situation. I just wanted to mention one other thing about the transmission and telemetry options. We could have a whole other webinar about our data transmission protocols. So there's a huge range of protocols that Garup offers, but we probably don't have time to go into that now. But chief among them is something called GDI protocol, which is minimum latency, extremely fast transmission. So we can probably go into that another time. If you'd like to know more about that, then please feel free to email James or myself.
Thanks, Will. I see Ricky Bolton has a question asking, do you have a factory reset button yet? Will, do you know the answer to this one?
I think I do. That has been a question beforehand. I believe that the firmware has been updated and the web page has a reset button in it. However, we don't advise it without first checking what the problem is with us. If there happens to be a problem that requires a factory reset problem, then we'd probably ask you to contact support first, just in case we can fix it another way before going back to the reset.
Okay, thank you all. If no one has any further questions, then I will end the webinar, and I will send the registrants a recording of the webinar and also a PowerPoint presentation that was shown today. But yeah, if you have any further questions, please feel free to contact myself or Will, or email sales@gurup.com, and hopefully see you guys around the booth at AGU. Thank you very much, guys. Bye.